Okay, let's go. Hill climbing algorithm. You try contacting the L's using your handheld device, but the river you're following must be too low to get a decent signal. You ask the device for a height map of the surrounding area, your puzzle input. The height map shows the local area from above broken into a grid. The elevation of each square on the grid is given by a single lowercase letter, where A is the lowest, B, blah blah blah, up to the highest of Z. Also included in the height map are marks for your current position, S, and the location that you should be able to get your best signal, E. Your current position, S, has an elevation of A, and the location that should get you the best signal, E, has an elevation of Z. You'd like to reach E, but to save energy, you should do it in as few steps as possible. During each step, you can move exactly one square up, down, left, or right. To avoid needing to get out your climbing gear, the elevation of the destination square can be at most one higher than the elevation of your current square. That is, if your current elevation is M, you could step up to elevation N, but not to elevation O. This also means that the elevation of your destination square can be much lower than the elevation of your current square. For example, balloon. Okay. Here you start in the top left corner, your goal is near the middle. You could start by moving down or right, but eventually you'll need to head toward E at the bottom. Okay. E, F, G, H, I, J, K, L, M, O, P, Q, R. Okay. That way. From there you can spiral around to the top of the call. Okay. In the above diagram, the symbols indicate whether the path exists, or whether the path exits each square moving up, down, left, or right. The location that should get the best signal is still E, and period marks your unvisited squares. This path reaches the goal in 31 steps, the fewest possible. What is the fewest steps required to move from your current position to the location that should get the best signal? Okay, so let's see, 31, and let's grab this input. And let's grab puzzle input. That is a decent enough size square. Okay. And these kind of things, there's really going to be two different ways, I think, major ways to go through it. One would be to do a recursion where you can look at basically every step that you can go to, and then for each of those steps, every step that you can go to again until you find the exit. The other option would be to kind of determine individual paths iteratively, which is more of a pain, but I kind of wonder with the second part if the size of the input's going to be more. Like the size that we have now, recursively would probably work no problem. If we go to a much bigger solution, probably not. Either way, we need to get our input into something that we can use. So since basically these are just going to be 0 through 25, we can just read that into an integer array. Should make it the easiest way to do it. And again, we already know the size of our array that we need. So this should basically go through and build our input into a two-dimensional array. So I'm just going to skip the build process again and walk through the implementation. I ended up not doing a recursive algorithm because of two main reasons. First, I still don't trust the second part at this point. I don't know what it's going to give me. It could have given me a much larger example. It could have thrown in some weird checks and stuff like that. Secondly, the paths can be circular. You don't always climb up to the next spot. Because of that, you could like step up, and then like down, and then you could go in kind of a circle. And those circles are hard to break recursively unless you pass in some sort of path variable, which is certainly doable. It's just easier sometimes to build it out iteratively in that case. And as I said, more likely to prevent any issues coming up in the second part. So basically what we are going to do is we have a min mountain, and this mountain is going to be the minimum path distance to the endpoint from every square. we started off with everything being in max value, minus a couple because we do some arithmetic on it and I don't want an overflow error. And then basically we're going to, after we bring our input in, we're going to build our min mountain, and we have a change value, and basically while we have change something, we're going to iterate over and over. And every time we iterate over, we're going to iterate over the entire mountain. So every square in the mountain, we're going to go through and check. We're going to check to see if the up value is got a path that's shorter than our current known path. Same with down, left, right. And so like for the up path, for example, if we have an up path, so if we're greater than 0, and the up height is less than or equal to our current height plus 1, so basically we could step up there, and the minimum known path for that spot plus 1 is less than our known path, then we're going to update our known path for this square, and we're going to mark change as true so we know that something has changed, and we're going to iterate over the entire loop again. Same thing with down, left, and right. Those are all the same. So after this runs, basically like it will run for the end spot, and then it will run for everything around the end spot, and then everything around those spots. And like every time something updates, the spots next to where it gets updated will go through, and it just expands and builds out the whole map basically. But once you've built that, you know the minimum distance from every spot on the path. And then basically, after we've built our input, all we need to do is return the minimum known path from our starting location. That's the right answer. Okay, so I just forgot to clear out the old numbers. Okay, you're 1 gold star closer. Part 2, as you walk up the hill, you suspect that the elves will want to turn this into a hiking trail. The beginning isn't very scenic though, perhaps you can find a better starting point. To maximize exercise while hiking, the trail should start as low as possible, elevation A. The goal is still the square marked E, however, the trail should still be direct, taking the fewest steps to reach its goal. So you'll need to find the shortest path from any square at elevation A to the square marked E. Again, consider the following example from above. Okay. Now there are 6 choices for the starting position, 5 marked A plus the square marked S that counts as the beginning of elevation A. If you start at the bottom left square, you can reach the goal most quickly. This path reaches the goal in only 29 steps, the fewest possible. What is the fewest possible steps required to move from the starting from any square with elevation A to the location that should get you the best signal? Okay, since we've already built our min mountain, which basically already contains the shortest possible path from every position, the only thing we need to do is figure out all the positions that have a start value of A. And actually, the easiest way might just be to go through the input again. So let's just copy everything from part 1. All right, so we're going to do this and build our mountain out. Great. And then after we build our mountain, what we're going to do is we're going to have a min path, which is going to just be int max value. And then we're going to do this exact same set of for loops. We're going to iterate through the input again. And then if input, if I could type, if input y of x is equal to a lowercase a, or if input y of x is equal to an uppercase S for the start position, as it's also an A, then min path is going to equal the min of min path and our min mountain at y and x. And then we should just be able to return min path and see what happens here. Exception check fail. Oh, I probably need to update the check to say 29. 386. That's in order with the other one. Cool. Well, that was an easy part too. Cool. All right, I will see you guys tomorrow.